Chapter 10 test review. Now, number 1, it says solve each equation in the interval. Boom. What that means is no negative spins. So only positive spins between 0 and 360. That's what it's saying. Don't ignore that little detail. That's important. The other thing is, something you've learned along the way, is never divide by the thing you're trying to solve for. What are we trying to solve for? X. So a lot of students would divide by sign, and it seems like you're doing the right thing, but you're not. We've talked about it in class. You're eliminating possibilities if you do that. So what you want to do is set this thing equal to 0 by adding sign to both sides, and 2 sine of x cosine x plus sine of x equals 0. Now you're able to factor out a sine. Now, don't think of this as 2 sines. Think of it as 2 times sine times cosine. In other words, this is sine to the first power. It's not sine squared. In other words, when I take this out, I am just taking it out. Some students get a little, I don't know, in their heads in that situation. And then this is what you end up with. So now you got 2 math problems. Where does sine of x equal 0? That's this. And where does 2 cosine of x plus 1 equal 0? Well, this one is one of those weird ones where you're looking at how in the world can sine be 0? Remember, sine is opposite over hypotenuse. So the only way is where opposite is 0. Where does the opposite side disappear? And it happens at 0 because there's my opposite. And it happens at 180 because there's my opposite. So there's 2 of my answers. X equals 0 degrees and 180. I'm not converting them to radians during the video. So this one we have to subtract 1, so we get 2 cosine of x equals negative 1. Divide by 2, we get cosine of x equals negative 1/2. Now you have to be careful here. All students take Calc. When you see the 1/2, your brain should be thinking, okay, that's probably a 30, 60, 90, because in a 30, 60, 90, we've got this situation where one side is half of the other side. The trick is our reference angle going to be 30 or 60? Now let's go one step at a time. Cosine negative. All things are positive. Cosine's positive. So we get rid of those 2 quadrants. So we know it's in this quadrant, this quadrant. Well, if you remember, cosine is the adjacent side over the hypotenuse. And if you remember, the adjacent side is always the x-axis. So you know to go out here negative 1, which means, if I draw it proportionately, this is my square root of 3 and this is my 2. And if I do the mirror image down here, this is negative square root of 3, this is positive 2. And the question really is, what's this? That's 60 and that's 60, but how far do you spin your spinner? Well, that's 120, so we're going to add that to the list. And then 240. So that'll squeeze that in over here. So we get 4 answers for that one little math problem. Seems harmless, but that's a lot of work. So in this situation, we do have sine squared, which means that's the same thing as sine of x times sine of x, if you want to think of it that way. And, whoops, I saw that as a 0. Sorry, I'm going to ignore that. Never mind. NM, as they'd text, you know. But this is a trinomial, so we're going to subtract 1. Whoop. 2 sine squared x plus sine x minus 1 equals 0. Now this is the same thing as 2x squared plus 1x minus 1 equals 0. Now, I'm not going to take forever to factor this, but if I factored it, I'd go 2x and x. This is a negative, so I know one of these has to be negative, one of them has to be positive, but which one? Well, we want more positive stuff, so I'm going to put the positive with this, because when we go outside, we're going to get 2x, and then if we go inside, we get negative. So I'm going to apply that thought to this problem. 2 sine of x, and then just sine of x, and then plus 1, minus 1. It's the same thing. And these are equal to 0, so we're going to start with this guy. where does sine of x equal negative 1? See, I just subtracted 1 and subtracted 1, and we got to take a look. How is this even possible? Well, the opposite and the hypotenuse, if that equals a 1, I'm going to ignore the negative a second. The opposite has to be a 1, and the hypotenuse has to be a 1. So remember where we said over here that 0, the opposite disappears, and 180, the opposite disappears? So that's very likely that the opposite, so here's the opposite, and here's the hypotenuse, are the same. Problem is, there's no negatives here. So 90 degrees, yeah, close but no cigar. But if I think about 270 and I flip my spinner really close to it and then go back here, here's my negative 1, my hypotenuse is 1, my adjacent is 0, but I have it. There's my opposite over my hypotenuse. That gives me what I want, so I know what x is. X is 270. It's one of my answers. Now I go over here. I'm going to add 1, so I get 2 sine of x equals 1, divide by 2, and I get a half. Again, it goes back to our 30, 60, 90, and this is my opposite, this is my hypotenuse, and so, but there's one more little twist. All students take calc. Where is sine positive? Here and here, not here and here. How can my opposite side be a 1? Only if this is a 30. And only if this is a 30. So one of my answers is 30. Another answer is 150. So if we stack that together, 30 and another is 150. So there's my 3 answers for that problem. All right, let's keep trucking. A little bit of a review situation. Write a possible equation for the given graphs. It says sine or cosine. So whatever whatever is easier, definitely use it. But in this case, I notice that this right here, if I was to just lift this up, I know that this right here, oh, actually, you know what? They're trying to draw our attention to concentrate on that little dot right there. So they're kind of inviting us to think of sine, because if I think of sine, y equals sine of x, we remember it goes through, it goes up to 1, and then down to negative 1, and then back to 0. And so that's kind of the parent function there. So if I focus on that dot and I ask myself, what happened? Well, it moved to the right pi over 2, and it also moved down 3 units. So how do I make sense of that? Well, I got y equals a sine of bx plus c plus d. I talked right pi over 2, so that's where this is going to be x minus pi over 2. And I think we've been kind of retrained to let that b come out here and then insert like brackets. So we'll stick with that. And then we also know that the midline was dropped down 3, so we're going to stick a negative 3 on the end there. The amplitude's easy to find because we can just see that it's 2 or 2. So we're going to take that. We're going to go 2 sine, and now we're on the hunt to find b. I didn't leave much space there, so let's pull this over. 2 sine, we got to find b. Well, if we just go from here to here, we can see that one period or cycle squeezed in there from 0 to pi. Now I just randomly picked those. You can pick from peak to peak if you want. But I'm going from here to here. I can see that that is pi. So the period formula is 2 pi all over b. We know the period is pi. So we're going to replace that with what we know it is. Now we're going to solve for b, so we're going to multiply by b, so I get b pi equals 2 pi. Divide by pi, divide by pi. These cancel, so b equals 2. So I'm going to put that right there. And slip a little y in there. So there's the one equation. that you could use, but they are drawing our attention to that little dot, so I went with it. So this one, what's the amplitude? It's right there, 2. Period. Well, there's our b, so we're going to use the formula. Period equals 2 pi all over b, which is 3. So there's our period. Horizontal shift, right here, we're going to go right 4, and this is going to go up 1. It doesn't have us graph it, so we're done. All right, let's get on to this one of these buggers. All right, got myself my handy-dandy calculator, and here we go. Now they're going to give this problem to us a little differently. Normally we had to discover this and then answer questions. Now they're just giving us the equation, trying to make it a little easier, but it is a little different, so it might throw you a little bit. So it says, where is the buoy, the height of a buoy bobbing up and down in the water is modeled by this sinusoid, with x representing time in seconds. Notice they're giving us 0 seconds and 7 seconds. So they're just saying, kind of let x equal 0 and let x equal 7 and find y, that's the height. So let's plug it in. This should be pretty easy because what's anything times 0? 0. So we're going to find cosine of 0. Now let's go to mode here. Right now it doesn't matter if it's in radians or degrees because 0 is just 0, but we'll talk about that in a minute. So cosine of 0, enter, is 1. So that's 1 times negative 5. Negative 5 plus 62 is 57. Now I'm going to make a little scratch pad here, and that's where it starts. 0, 57. Now the reason I didn't put it way up here is I can see that this is going up 62, so whatever. I just put it, it's just a total random guess. Now I'm going to plug in x is 7. So I see this. Now I can see that pi over 6 is 30 degrees. 30 times 7 is 210. So I'm going to go to my calculator because I'm using 210. I want degrees, clear that, cosine of 210, and then I'm going to multiply that by negative 5. That's 4.33 plus 62. So let's go ahead and add that to 62, and I get 66.33. Now I'm going to double check my work here, but 7 seconds we'll put out here, and now it's saying 766.3 we'll call it. So give me a second. Okay, so double checked my work and it came out. I was just for some reason expecting a whole number, but never happens. Doesn't always happen. So 66.3-ish, really close. Okay, so now it says what's the maximum height of the buoy, what's the minimum height of the buoy. So this is something you have to kind of wrap your brain around. Okay, so letter B, asking again, what is the maximum height of the buoy, the minimum? What I did was I drew the parent function, y equals cosine of x, just so we can remember some basics. Now my opinion is, my technique that I'm about to show you is going to like on things, and then you're going to go, wait a minute, it was a lot easier than that. Well, let's take a little picture of this story by just graphing it. So remember the midline of your parent function is right here, and there's a plus 0 there essentially. That's why it's there. This goes up 62. So what I'm going to do, I'm going to get rid of that little rando dot there. I'm just going to grab this right here, and I'm going to say that's 62. And now we're going to mess around with this. This is not going to be to scale. But I do know that it's going to be a reflection on top of everything else. So, but the thing I want to really talk about is no matter where this graph is, it's going to have a peak. It's going to be up 5 above the midline. That's basically what the amplitude does. And that takes us up to 67. And it's also going to go below the same distance, again, not to scale, and that would take me 5 units below this, which would be 57. Now, something I want to make clear to you is, this kind of takes us back, which makes this problem a little easier actually, that the starting point at 0 seconds, that's really not level, but would be right at 57. So 0.57 without telling us directly, they gave us one of the minimum points right there. Now we're going to make sense of this in a different way, but let's just keep going. So what's the maximum height of the buoy? 67. What's the minimum height? 57. So that's pretty easy once you get that drawing. A different way to think of this is the maximum height for cosine, no matter how far out you go this way or how far out you go that way, is going to always be 1. The minimum is going to be -1. So this stuff right in here, your basic knowledge of cosine, kind of helps you. Because what's the biggest number this can be? 1. 1 times -5 is -5. -5 plus 62. Well, yeah, 1 times -5 is -5, plus 62 is 57, so it spits it out if you just use a little common sense. The lowest this could be is -1. If we pop that in there, -1 times -5 is 5, 5 plus 62 gives us a 67. You could do it with just sheer common sense, knowing your parent function. But I think most of you would probably go down this road. That's what I'm thinking. Okay, and then it asks, what's the period? And we can bang this out by just looking at this. So period equals 2 pi all over b. b is pi over 6. Remember, if you have a fraction down there, you're going to flip it and multiply. So these cancel, and our period would be 12. So it takes 12 seconds for it to complete one cycle. That finishes that problem. We're going to go on to part 2. So that ends this. Like and subscribe. Let's go viral, guys.